Hello, friends. Today we will analyze the role of reinforcement bars in a reinforced concrete beam. Why reinforcement is placed in certain areas of the beam, why it has a particular shape, and also why it is placed in some places more often than in others. We will analyze all these questions using the example of the simplest design, a single-span reinforced concrete beam working and bending from a vertical load from above. Let's imagine a beam with a span of 6 meters, located on two supports at the edges. When we apply a load to it, it bends. This will happen at any cross-section, large or small. The difference will only be in the magnitude of the deflection. Bending leads to internal stresses in concrete and reinforcement. Even without deep knowledge of strength of materials, it becomes clear from the shape of the bend. The lower part of the beam is stretched and the upper one is compressed. From this, it is logical to draw the conclusion: closer to the lower part of the beam, it is necessary to place reinforcement so that it does not crack or collapse under the action of tension, because concrete is almost incapable of withstanding such loads. The lower reinforcement in the beam serves precisely to withstand tensile forces. But then the question arises, why do we need reinforcement in the upper part if the concrete is compressed there and therefore copes with the load better? The fact is that sometimes the compressive stresses in the beam are so great that even in the compression zone, reinforcement in the form of steel reinforcement is required to help the concrete resist. However, most often in such single-span beams, upper reinforcement is used for design reasons. Let's look at three main reasons. The first is that the upper longitudinal reinforcement prevents concrete from cracking during hardening and shrinkage. The second is that it is necessary during installation when the beam is lifted by a crane or installed in place. At such moments, variable and dynamic loads arise, and it is not always possible to do without the upper reinforcement. The third reason is that it serves to fix the transverse reinforcement, which we will now move on to. It would seem that if the beam is subject to tension from below and compression from above, transverse reinforcement is not necessary. But this is not the case. Transverse reinforcement is necessary for two reasons. Firstly, structurally, it unites the lower and upper longitudinal reinforcement into a rigid frame. This prevents the longitudinal rods from shifting during concreting. Secondly, if significant transverse forces arise in the area of the beam supports, then transverse reinforcement, in the form of clamps or individual rods, is installed according to calculations so that the concrete does not collapse under the action of these transverse forces. Since transverse forces are maximum precisely on the supports and decrease toward the center of the beam, the step of installing transverse reinforcement closer to the supports decreases, and in the middle of the beam, it increases. In the central part, as a rule, it serves only to maintain the shape of the frame during concreting. There are two main types of transverse reinforcement. The first is solid bent stirrups used for reinforcement diameters of 6 to 8 millimeters. They are easy to bend and install by hand. The second is welded frames with straight rods, used for larger diameters or where manual labor on the construction site must be minimized. Such spatial frames are manufactured at the factory using spot welding and are installed in one piece into the formwork. Today we have considered the simplest case of reinforced concrete beam operation. But in modern monolithic buildings, beams experience much more complex types of loading, including even torsion. We will examine such cases in detail in the following videos. I wish you quality projects and beautiful structures. See you there.